Earth Science, Module 2, Rocks and Minerals. Content Standard, the rocks and minerals. Most essential learning competencies are identify common rock-forming minerals using their physical and chemical properties. B. Classify rocks into igneous, sedimentary, and metamorphic. Learning objectives: demonstrate understanding about physical and chemical properties of minerals. B. Identify some rock-forming minerals. C. Identify and describe the three basic rock types. D. Understand the different geologic process involved in rock formation. What are minerals? These are naturally occurring inorganic solids with crystalline structure and chemical composition which may be fixed or vary within certain limits. Although thousands of minerals in the earth have been identified, just 10 minerals make up most of the volume of the earth's crust, namely quartz, plagioclase, orthoclase, amphibole, pyroxene, olivine, calcite, biotite, garnet, and clay. There are 6 characteristics of minerals. A. Naturally formed. It means no man-made substances. No substance created artificially is a mineral. B. Inorganic. Also known as a non-living form. Anything formed by a living organism and containing organic materials is not a mineral. Solid. Liquid and gases are not considered minerals. D. Characteristic crystalline structure. It must have an ordered arrangement of atoms, display repetitive geometric patterns in 3D. It means it has a typical ordered internal structure, and a glass is not a mineral because it has no internal crystalline structure. E. Definite chemical composition. It must have a consistent chemical formula, for example, gold, quartz, and ordinates. And this is are the 6 minerals characteristics. We have the naturally occurring, inorganic, solid at room temperature, a typical ordered internal structure, and a definite chemical composition. Minerals can be identified by their physical characteristics. The physical properties of minerals are related to their chemical composition and bonding. Some characteristics, such as a mineral's hardness, are more useful for mineral identification. Color is readily observable and certainly obvious, but it is usually less reliable than other physical properties. So these are some physical properties of minerals. We have color. Color is often useful but should not be relied upon. Color can help but do not rely on color as determining property. The different minerals may be the same color. Next is streak. Streak is the color of a mineral's powder. Streak is a more reliable property than color because it does not vary. Minerals that are the same color may have a different colored streak. Many minerals such as quartz do not have this kind of streak. To check streak, scrape the minerals across an unglazed porcelain plate. A yellow gold pyrite has a blackish streak. Another indicator that pyrite is not gold, which has a golden yellow streak. While the color of a mineral may vary from sample to sample, the streak usually doesn't. Therefore, a streak can be a good indicator. Next physical properties of mineral is luster. A luster is usually used to describe how light is reflected from the surface of a mineral. One of simple way to classify luster is based on whether the mineral is metallic or non-metallic. Minerals that are opaque and shiny, such as pyrite, have a metallic luster. Minerals such as quartz have a non-metallic luster. Next is minerals with a non-metallic luster are described by many adjectives: vitreous, glassy, earthy, and pearly. Another physical properties of minerals is hardness. It is one of the most useful properties used to identify a mineral. It is the strength with which a mineral resists its surface being scraped or punctured. Hardness is a measure of the resistance of a mineral to being scratched. You can find this property being rub or rubbing the mineral against another mineral of known hardness. Okay, so in working with hand samples without specialized tools, mineral hardness is specified by the Mohs hardness scale, also by residual absolute hardness and Baker's hardness test. The Mohs hardness scale is based on reference minerals from talc, the softest, most hardness of 1, to diamond, the hardest, the most hardness of 10. So based from the given table, mineral, we have the following mineral here. The given minerals, which is talc being the softest, the most relative hardness is 1, and then followed by gypsum, calcite, fluorite, apatite, orthoclase, quartz, topaz, corundum, and diamond being the hardest, which has most hardness of 10. And same thing with the other hardness test, which is the residual absolute hardness, and the Baker's hardness test, which measures the hardness of a mineral. Next, crystal form. All minerals are crystalline, but only some have the opportunity to exhibit the shapes of their crystals or their crystal form. Crystal form is the visible expressions of a mineral's internal arrangements of atoms. Every mineral has a distinct crystal form. And these are some of the examples of crystal shapes and forms. Next is cleavage. Cleavage is the tendency of a mineral to cleave or break down along flat, even surfaces. This break tends to be along the weakest part of the mineral structure. A mineral that naturally breaks into perfectly flat surfaces is exhibiting cleavage. Not all minerals have cleavage. A cleavage represents a direction of weakness in the crystal lattice. Next is fracture. All minerals have fracture. Fracture is breakage which occurs in directions that are not cleavage directions. Minerals that do not show cleavage when broken are said to fracture. Fracture is the uneven breakage of a mineral. Another physical properties of minerals is density. Density is the property of all matter that is the ratio of an object's mass to its volume. The density of a pure mineral is a constant value, so it can be used to determine the purity or identity of some materials. Some minerals have very distinctive properties as well. Calcite has what is called double refraction, which means that although it is transparent, it doubles the image of whatever is behind it. Other identifying characteristics. Some minerals have unusual properties that can be used for identification. We have here smell. Some minerals have a distinctive smell. Sulfur smells like rotten eggs. So streaks of mineral that contain sulfur will smell like rotten eggs as well. Next is magnetite. Magnetite is an example of mineral wherein the property is known as magnetism. Mineral is attracted to a magnet. Magnetite and hematite are magnetic and will attract paper clips and small nails. Other identifying characteristics of minerals, we have fluorescence. Mineral glows under ultraviolet light. Example of mineral, fluoride. Next, we have radioactivity. Mineral gives off radiation that can be measured with Geiger counter. Example of mineral is uraninite. And reactivity, bubbles form when mineral is exposed to weak acid. Example of mineral is calcite. And taste is some mineral taste salty. That is one of the example is halite. A mineral's properties depend upon the elements that compose the mineral and its structure. When identifying a mineral, you must look at it closely on all visible sides to see how it reflects light, test its hardness, identify its cleavage or fracture, name its luster, as well as evaluate any other physical properties necessary to determine the mineral's identity. Next, we have classifying minerals. The chemical basis for classifying minerals is the anion. The negatively charged anion, which usually shows up at the end of the chemical formula of the mineral. For example, we have sulfides are based on the sulfur ion. Such example is pyrite. And we have mineral class of an ion in polyatomic ion, which is the carbonate ion. Other major classes of minerals in classifying minerals are silicates, sulfides, carbonates, oxides, halides, sulfates, phosphates, and native elements. These are the most abundant minerals in Earth's crust. So we have here an illustration wherein a plagioclase feldspar consists of 39% of minerals in the Earth's crust, followed by the alkali feldspar and quartz, which consists of 12%, and pyroxene 11%, and then we have here the non-silicates 8%, and then clays, micas, amphiboles, those are 5%, and the other silicates is 3%. How is a rock different from a mineral? In our previous discussion regarding mineral, a mineral is a naturally occurring inorganic solid with a definite chemical composition and a crystalline structure formed by geological processes, while a rock is an aggregate or combinations of one or more minerals, which includes organic remains and mineraloids. Then we have here a rock. A rock is naturally formed, a non-living earth material. It is made of collections of mineral grains that are held together in a firm, solid mass. We have here a basic rock collection. So based from the pictures, it's shown the different kinds of rocks formed by igneous, metamorphic, and sedimentary. We have here the igneous, the granite, the lava, the rhyolite, the porphyry, the obsidian, and the pumice. This is sedimentary rocks, which includes conglomerate, limestone, sandstone, travertine, shale, and dolomite. And metamorphic, which includes gneiss, marble, mica schist, anthracite, slate, and quartzite. Those are some examples of different kinds of rocks formed by igneous, metamorphic, and sedimentary. What are rock-forming minerals? Rock-forming minerals are any mineral that forms igneous, sedimentary, or metamorphic rocks that typically or solely forms as an intimate part of rock-making processes. To be considered a common rock-forming minerals, be one of the most abundant minerals in Earth's crust, be one of the original minerals present at the time of crustal rocks formation, and be an important mineral in determining a rock's classifications. So those criteria considered in the most abundant minerals in the Earth's crust. Then next we have, these are some examples of the influence of just few minerals. Minerals in the sedimentary cover. This consists mainly of clastic rocks such as sandstone, siltstone, and shale, along with carbonate rocks such as dolstones and limestones. These plastic rocks are composed of mainly quartz, clay minerals, and a small amount of micas and feldspar minerals. The carbonate rocks consist of primarily calcite and dolomite. A small number of materials composed of a small number of minerals make up of the most of the sediment and sedimentary rocks that cover the continents and ocean bases. Minerals of the oceanic crust. The oceanic crust is mainly composed of basalt and gabbro. These two rock types are made up of mainly of plagioclase feldspar and pyrocids. With smaller amounts of olivine and micas and amphibole, this small group of minerals makes up of the most of the rocks of the oceanic crust. Minerals of the continental crust. The continental crust is made up of mainly of rocks with granitic to andesitic composition. These rocks are composed mainly of alkali feldspar, quartz, and plagioclase feldspar with small amounts of amphiboles and micas. This small number of minerals makes up most of the continental crust. There are three main categories of rocks. We have igneous rocks. These rocks are formed by cooling of molten rock, either magma or lava. Sedimentary rocks. These rocks are derived from pre-existing rocks through the processes of erosion followed by compactions or chemical precipitation. Metamorphic rocks. These rocks are recrystallized by pressure and heat that may or may not be influenced by the introductions of chemically active solutions. These rocks are formed when the minerals in an existing rocks are changed by immense heat or pressure within the earth. Rock cycle. This is the process that completely portrays the complex and interconnected transformation of rock from one category type of rock to another. The rock cycle diagram clearly shows all the steps, components of the rock cycle, including the end results and the movement of the process. This is another diagram or illustrations of rock cycle wherein the magma cools inside crust known as intrusive, lava cools and hardens outside crust known as extrusive. So from cooling it turned to igneous rocks wherein all rocks erode and weather to small sediments, and this wearing away of rock is known as erosions. And then breaking down of rocks is known as weathering. So sediments are carried by wind and water. That is one of other sources of agents. And then sediments, wherein sediments get pressed, pressured together to form hard sedimentary rocks, and the rocks can go back into earth through subductions and folding, and heat and pressure change rocks to metamorphic rock. And then melted rock may then find its way to the surface, starting the process all over again. So, based from this diagram or illustrations, there are different arrows indicated wherein it can be transformed from one type of rock to another. What are the processes involved in rock formation? Processes of the rock cycle. Number 1, crystallization of magma. Magma is the liquid form of rocks under great pressure and temperature due to heat from the earth's core. As the magma cools, different crystals form at different temperatures. Weathering, a process of breaking down rocks into smaller and smaller particles without any transporting agents at play. Factors like temperature extremities, biological involvement of nature and water plays the main role. It can be broken down into chemical, physical, and biological influencing agents. Number 3, erosion. Erosion is the natural process of breaking down rocks into sand-like particles. Running water, ice, and gravity all transport these sediments from one place to another. Number 4, sedimentation. The sediments are laid down or deposited. Sediment is the constant deposition or settling down of small particles of sand, pebbles, that is broken down from rocks. 5, burial and compaction. When it is sedimented, it creates layers which are soon covered by another layer of new sediment, and the process goes on. This gives rise to pressure on the sedimented layers below. Next is 6, metamorphism. The constant pressure and sudden movements put some sedimentary and igneous rocks under great pressure. The rocks deform to create metamorphic rocks. Deformation basically means folding and folding of rocks. This is caused by compression and tension. When a rock is exposed to extreme heat and pressure within the earth but does not melt, the rock becomes metamorphosed. Rock forming processes. Based on the illustration, we have here the type of rock and source of material, the rock forming process, and its example. We have the igneous rocks, melting of rocks in a hot deep crust and upper mantle, which is the rock forming processes is crystallization, solidification of magma or lava, which is some of the example of this is coarsely crystallized granite. Sedimentary, weathering and erosions of rocks exposed at surface, deposition, burial, and latifications, and one of the examples is the bedded sandstone. And next we have metamorphic, the rocks under high temperatures and pressure in deep crust and upper mantle. The rock forming process is recrystallization in the solid states of new minerals, and one of the examples is gneiss.
Rocks are everywhere. They are large and small, heavy or light, porous or dense. But rocks in some shape or form can be found all over the planet. Different types of rocks are formed in different ways. There are 3 main types of rock: igneous, sedimentary, and metamorphic. Igneous is a word that means fiery. Igneous rock is formed when magma or lava cools. Sometimes magma cools slowly underneath the Earth's surface. This forms intrusive igneous rock, like granite. Other times, lava cools when it comes to the surface in a volcanic eruption. This forms extrusive igneous rock. Some examples of extrusive igneous rock are tuff, obsidian, and pumice. Igneous rocks make up about 95% of the Earth's crust. The next type of rock is sedimentary rock. Sediment is small particles of sand, mud, and organic material that settle to the bottom of water or land areas, often lakes or oceans. Sedimentary rocks are formed when sediment accumulates over time in deposits that form layers. These layers become squeezed and compressed over time until they consolidate into a rock. Sedimentary rocks are the types of rocks in which fossils may be found, since the process of forming sedimentary rocks can preserve plant and animal remains that are deposited into the sediment layers. Some examples of sedimentary rock are limestone, shale, and sandstone. The third type of rock is metamorphic rock. The word metamorph means to change form, and metamorphic rock is rock that has been changed by extreme heat and pressure. Sedimentary rock, igneous rock, or even other metamorphic rocks can be changed by heat and pressure into new kinds of rock. Metamorphic rocks can be formed by being deep under the earth where pressure and temperatures are high, or when rock near the surface is heated up by the movement of tectonic plates or magma. Different types of rocks become different types of metamorphic rock when exposed to heat and pressure. For example, shale becomes slate. Sandstone becomes quartzite. And limestone becomes marble. Rocks are slowly but constantly changing in something known as the rock cycle. The rock cycle begins with magma, or hot melted rock, deep beneath the Earth's surface. This magma becomes crystallized, becoming igneous rock. These rocks begin to erode or break down into small pieces because of wind, water, or other forces. The small fragments of rock are carried away as sediment when water passes over them and are deposited in layers, which eventually become sedimentary rocks. Then, some sedimentary rocks are pushed below the surface due to tectonic activity, where they are exposed to heat and pressure, transforming them into metamorphic rocks. If the rocks are buried even deeper, they may melt and form magma, starting the cycle all over again. Of course, sedimentary and metamorphic rocks can be eroded into sediment, and igneous rock can become metamorphic rock or lava. But one way or another, rocks all over the world keep changing from one form to the next.
How important rocks and minerals in our daily life? Rocks and minerals are important. They have a broad range of uses that makes significantly important to human life, which includes as building materials, for manufacturing substances, making medicine, and also used to produce electricity. We have here a common mineral uses. We have here some minerals and uses: bauxite, aluminum foil, plain parts, calcite, medicine, toothpaste, building materials, copper, electrical wires, sculptures, diamond, cutting tool, gemstone, graphite, pencils, lubricant and in machinery, gypsum, wallboard, halite, soap, quartz, electronics, radios, computers, silver, jewelry, photography, electrical equipment, sulfur, fungicides, kills bacteria, fertilizers, and talc, baby powder. We have here the importance of rocks and minerals. We have here the different kinds of rocks and the type of rocks and its uses. We have here the basalt, the igneous, used in road building materials, calcite, mineral, used in cements, mortars, and the productions of lime, granite, igneous, which is used for building monuments and tombstone, marble, metamorphic, used in building floor tiles in bathrooms, obsidian, igneous, used in making arrowheads and knives, pumice, igneous, used in scoring, scrubbing, and polishing materials, quartz, mineral used in making glass, electrical components and optical lenses. Sandstone, sedimentary, used in the building industry for houses. Slate, metamorphic, used for roads, chalkboards, and fascia walks. And we have here a group activity. Activity sheet 1.1. Supply the missing boxes of the following with the provided choices in the box. And then activity sheet 1.2, we're going to answer the following guide questions. Number 1, based from the given activity, why is it called a rock cycle? Number 2, what are the rock cycle processes? Number 3, how does rock cycle happen? Number 4, how do humans affect the rock cycle and how does the rock cycle affect us? And these are some of the references of our lesson for today.